Okay, there you're given in the first question, you're given 2 points P and Q, and you're asked to use vectors to answer the following question. Find the midpoint of the line segment connecting P and Q, and find the point on the line segment connecting P and Q that is 3/4 of the way from P to Q. Okay, so if you want to look at the point that's halfway between P and Q, then again, so then again what you do is, so you let PR be U, and U is the vector again. It's x minus 2, y minus 3, and z plus 2. And again the vector PQ, call that the vector V, and that is going to be the vector 5 minus 7, 3. Now we need to find the point that's halfway between the two, and again that is very simple. You want basically, so you're looking at U being that vector there, and so you need U to be half of the vector V, and that is then just going to imply that x minus 2, y minus 3, z plus 2 needs to be 5 over 2 minus 7 over 2 and 3 over 2. And again, that's going to imply that x is going to be 9 over 2, y is going to be minus a half, okay, and z is going to be again also minus a half. Alright, so R, the point halfway, halfway between P and Q it's going to be the point 9 over 2 minus a half minus a half. Okay. Okay, so next we are asked to basically, again, you consider those 2 points. You consider the point 2. Let me just fix that. Right, so you are to consider the point 2, 3 and minus 2, that point, and this point here, which is the point 7 minus 4, 1, and you're asked to find the point, but you're asked to find a point there. Okay, so you look at the vector there, and you're asked to find the point there, x, y, z, that is, it's 2/3 the way from P to Q. Okay, so there's P and there's Q. Right, so you want that point to be, you want this point x, y, z to have that property. Okay, so again, so you can let U be the vector, right? So let's call that point R. So let okay, so P R, vector PR be U, and PR is basically going to be the vector x minus 2, y minus 3 and z plus 2. And we look at the vector PQ, right, which is, let's call it V. And that is the vector, what did we say? At 7 minus 2, which is 5, minus 4 minus 3, which is minus 7, and 1, and then you've got 1 minus minus 2, which is 3. Right, so what do we need to find that point? We need U to be 3/4 of V. And then it's just simply solving. So basically you want U, which is x minus 2, y minus 3, z plus 2. You want that to be 3/4 of V. All right. Okay, so that then implies that basically that x is going to be 15 over 4 plus 2, which is 23 over 4. Okay, and y minus 3 is going to be equal to minus 21 over 4. So that's going to be minus, so y is going to be and then lastly z is going to be 9 over 4 minus 2. Right, so that is going to be 1 over 4. All right. So, right, so your point, so the point R, so R is basically the point 23 over 4. Minus 9 over 4 and 1 over 4. Okay. Okay, question 2. You're given two vectors in 2 or 3 space, U and V, where we use norm is K and V's norm is L, and you're given the vector W, and you're asked to show that W intersects the angle between U and V. All right, so let's look at this problem. So you're given the vector U. You are given the vector V, and you're given the vector W. Right, and W is this vector. It's the vector LU plus KV. Right, now we can label this angle here as the angle theta 2, and we can label this angle here as theta 1. So what we know is, we know that the cosine of theta 2 is basically expressible as a dot product. So it's a dot product between the vector V and W divided by the norm of V multiplied by the norm of W. Okay, and that is equal to, it's V's dot product with the vector LU plus KV divided by the norm of V multiplied by the norm of W. And using our rules, we get that v dot u plus k v dot with itself, we know what that is, divided by the norm of v multiplied by the norm of w. Right, so we know that that is equal to, it's L v dot u divided by the norm of v multiplied by the norm of w plus k. What is v dot v is, it is the norm of v squared, and we know that what do we know about the norm of v? The norm of v is L multiplied by the norm of w. Okay, and from there we have that we know the norm of v is L, so that's going to be equal to v dot u divided by the norm of w plus, we know L is the norm of v, so that's going to be the norm of v, and we know k is the norm of u, so that's going to be the norm of u divided by the norm of w. So that is what the cosine of theta 2 is. So next we need to look at what the cosine of the angle theta 1 is. Alright, so now we need to look at what is the cosine of the angle theta 1. So I'm just going to create a new vector here. I'm going to call that the vector E, and I'm going to just let E be the unit vector formed by normalizing the vector U. So I'm going to multiply the vector U with 1 over the norm of U. Okay, and also note that the norm of E, remember the norm of E is 1. Okay, so now the angle between the vector W and E is the same as the angle between the vector W and U. Okay, E is just the unit vector, it's a normalized unit vector. Right, so basically what I want is the cosine of theta 1 is going to be equal to the dot product of E with W divided by the norm of E multiplied by the norm of W. Right, so that is equal to, the norm of E is 1. Okay, so that E, you're going to dot with the vector LU plus KV, and you're going to divide that by the norm of E, which is 1. So you're dividing by the norm of W, and then taking the dot product of all of those things. That's going to be L by our dot product rules, E dot U, all right, plus K E dot V. Divide everything by the norm of W. Okay, so what is all right, so doing the substitution, so what is E? E is basically, it's the vector U divided, multiplied with the scalar 1 over K. Okay, and you're going to dot that with U plus, what is E again? It is 1 over K U dot v multiplied by k. And you're going to divide all of that with the norm of w. Okay, then resuming from here, resuming from there, we then get that we get u dot, that is equal to u dot u multiplied by L over K, right, plus u dot V. And you're going to divide that by the norm of W. Sorry, let me just fix that. The norm of W. And you're going to also divide that by the norm of W. So therefore you've got L over K multiplied by the norm of U squared plus U dot V divided by the norm of W. And you're also going to divide that by the norm of W. Right, so what is the norm of U again? It's K. So those K's cancel and you're left with L, the norm of U, divided by the norm of W, plus U dot V divided by the norm of W. And that L is basically the norm of V. So the norm of U divided by the norm of W plus U dot V divided by the norm of W. Right, now you can see that the cosine of theta 2 is equal to this expression, and the cosine of theta 1 is equal to that expression there. So by comparing the expression, you see that they both are the same. So this implies that the cosine of theta 1 is exactly the same as the cosine of theta 2. They are exactly equal to the same number. Right, so from there what we have is just one note. We may assume, that this angle here, theta, which is theta 1 plus theta 2, remember we said the angle between U and V, the angle between U and V, you know, we can call that theta. And there's the vector W. Just one note that you can say that theta is between 0 degrees and 180 degrees. And if you look at cos from 0 to 180 degrees, it's basically going to look like that. And on that interval there, on that interval, we know that the cos graph is 1 to 1. So for any angle between 0 and 180 degrees, if you take two angles between 0 and 180 degrees, the cos of the one angle, if the cos of the one angle is equal to the cos of the other angle, then the two angles are going to be equal, because in that interval the function is 1 to 1. Alright, so this implies that as the cosine of theta 1 is equal to the cosine of theta 2, theta 1 is equal to theta 2. You may assume that it is, like I said, you may assume that it's between 0 and 180 degrees, because if the angle between you and V is more than 180 degrees, well, I mean, we can just basically take, we can just take that angle. The next one, consider two planes with given equations. Using vectors, find the obtuse angle in degrees between these two planes and round off to the nearest tenth. Okay, so we need to firstly get an idea of what these two planes look like, where they intersect, and then get the angle between those two planes. Okay, so the first step is we need to just get more or less an idea of what the two planes, what they look like. So we've got the plane x plus y minus z is equal to 0, and we have the other plane which is x plus 2y minus 3z equals to 0. Now you can look at the zx projection. So the zx projection is where y is equal to 0. So you're looking at the line x equals z, and you're looking at the line z equals a third of x. Right, so that is, so if you look in the zx plane, right, so that is basically is your line, is your x equals z line, and that there, or rather I should actually be more specific there, that there is your z equals a third of x. Okay, so they're the 2 points there. So that's the projection on the zx plane. And then if you look at the xy projection, so the xy projection is basically going to be, then you're going to deal with the line y equals minus x, and you're going to deal with the line when you make z equals to 0, you're going to look at the line y equals minus a half x. Right, then, so that's the xy projection. All right, so that basically, that you can see this here, that line there is the line y equals minus x, okay? All right, and you can't see it now from here, but that line there is the line y equals minus a half x. That's minus a half x. Okay. Okay, and where are these two planes equal to one another? So where is the plane x plus y minus z? Where is it equal to the plane minus x minus 2y plus 3z equals 0? I just took the second plane and I multiplied through by minus 1. If you have, that's your first plane and that's your second plane. If you add the two together, you're going to get minus y is equal to 2z. Right. Okay, adding the two together, you get basically minus y plus 2z equals to 0, which implies then that you can go and solve for z as a half of y. And then just substitution, the first equation, you can go and solve for x as x plus y minus a half y equals 0, which again implies that x is equal to minus a half of y. Okay, so planes intersect. They basically intersect, so we can parameterize this line. So that's going to be minus a half t. You can make xt, and you get a half of t for z. Okay, so this, and that's where t is any real number. Okay, so basically, so what we have here is this point here is a straight line, and that straight line, I'm going to indicate that straight line so you can see. So they intersect basically in this straight line, that straight line there. Okay, that's just a section of that straight line. Okay, so that's that line there. I've just drawn a point on that line, which is minus a half, 1 and 1/2. Okay. Okay, so now that we know more or less what it looks like, what's the angle that we want? First of all, the acute angle between the two planes is basically going to be this angle, okay, which is, I mean, it's running through that way there. And so those are the two angles. And then basically the angle that I'm basically interested in is the obtuse angle between these two planes. So that's basically going to be that angle there. Okay. So let's work out that angle first, and then you know, from that you can. So it's essentially basically, yeah, it's basically that angle there that I'm interested in. So once I have the acute angle, I can get the other angle. All right. So basically, what I'm going to do is I'm going to take that vector, and I'm going to take that vector there. So basically that is, if you go and redraw it, there we've got the vector 1, 0, 1, and there we've got the vector 1, 0, third. Okay, and we can call that vector u and vector v. And now we know that the dot product, or the cosine of the angle between the two, which is that angle there, is going to be the dot product between 1, 0, 1, dot product, 1, 0, a third. Okay, and you're going to divide by the norm of the vector u, which is basically the square root of 2, multiplied by the norm of the vector v, which is the square root of 1 plus 1 over 9, which is the square root of 10 over 9. Right, and that is then going to be equal to, get the dot product of that there, it is going to be 1 plus a third, which is 4 over 3. Okay. Divided by the square root of 20 over 9. Okay, and continuing from there, we get then that is 4 over 3 multiplied by 3 over the square root of 4 times 5. And that is then going to be 4 divided by 2 times the square root of 5, and basically that's going to be equal to 2 times the square root of 5 divided by 5. Okay, so the obtuse angle is basically going to be equal to. Sorry, I didn't say anything. Let's call it the obtuse angle theta is basically going to be theta. It's going to be 180 degrees minus the cosine of minus the inverse of that. Okay, and that is going to be 153.43 degrees. Okay, it's more or less equal to that. Okay, question 4. Under what conditions will the triangle inequality be an equality? Explain your answer geometrically. So to do this, we need to go back to the proof of the triangle inequality. Right, so they ask us under what conditions do the triangle inequality, under what conditions do we have equality in the triangle inequality? So here we've got, remember in one of our lessons we proved this whole statement, okay, for the triangle inequality. So where does the inequality come in? It comes there, right there, and basically there. So we need to ask ourselves now, when will equality occur? So when will it, for the first inequality, when will equality occur there? So that is when u dot v is the same as the absolute value of u dot v. In other words, the dot product between u and v is a positive number. Now remember that the dot product between u and v, we said that's defined as the dot product between u's norm multiplied by v's norm multiplied by the cosine of the cos of the angle between the two. That's only going to be positive. Right, so this dot product here is going to be positive only when, look at the cosine graph, that's when the angle between, the angle between the vectors is between negative pi over 2 and positive pi over 2, and theta is between 3 pi over 2. Sorry, that I should actually say not and, or theta is between 2 pi, or theta is between negative 3 pi over 2 and minus 2 pi. Okay, so that's the only condition for when it's positive. You need for equality to occur, you need the first place where the inequality arises. You need to have equality there. So the angle is going to have to lie in those quadrants there. And the next part is this part here, which is that from there to there. And the only way equality occurs there is when you have the following. Okay, so again, remember that if you look, so your angle lies in those quadrants, so you can now assume that u dot v is positive. Okay, so therefore, remember this is true. So now we need to go a little bit deeper. Okay, right, note that if theta is between 0 and pi over 2, or theta is strictly between 3 pi over 2 and 2 pi, or theta is between 0 and minus pi over 2, or theta is strictly between minus 2 pi and minus 3 pi over 2, then what do we know? We know that u dot v is going to be strictly less than the product between the norm of u and v. Okay, and that is because for in these mentioned intervals, cos theta is going to be strictly between 0 and 1. All right. Okay, so this implies that basically you need theta to be 0, or it can be pi over 2, okay, or it can be minus pi over 2, or it can be 2 pi or minus 2 pi, right? Right. Or minus 3 pi over 2, 3 pi over 2. Okay. So now geometrically, what does that mean if you look at the vector u and v? If you look at the vector u and v, either u and v have an angle between them that's 90 degrees. That occurs when theta is pi over 2, or theta could possibly be minus pi over 2. And in that case, the angle between u and v is also 90 degrees. In the case where theta is either minus 3 pi over 2 or 3 pi over 2, you also have a situation where the angle between u and v is 90 degrees. So in both those cases, all four of those cases, u and v are orthogonal to one another. And then you have the last case where the angle between u and v is either 0, 2 pi, or minus 2 pi, and that's geometrically equivalent to u and v pointing in the same direction. So geometrically, equality occurs only when the angle between u and v is 90 degrees, in other words, u and v is orthogonal, or the angle between u and v is 0 degrees, and in that case, u and v point in the same direction. Okay. So that's what it means geometrically. So if u and v are orthogonal, then you actually you have equality, and when the angle is between them is 0 degrees, you also have equality.